Hi, my name is Uday Darshiana from Prakash. My matrix ID is 823CS5047. So this video's purpose is for me to demonstrate all sorts of sorting techniques, and the topics that will be covered is bubble sorting, insertion sorting, selection sorting, quick sorting, and also merge sorting. So the first sorting we are going to do is the bubble sorting. Here, as we can see, we have 10 numbers. So just imagine that these numbers are contestants who are competing to get in the correct order from the smallest to the largest. But there is a twist that only the smallest can stay ahead after each lap. So here is how it is going to work. Each bubble is compared with its neighbor. So for example, this 29 is compared with 10. So because 10 is smaller than 29, we are going to swap those places so that the 10 is in front and the 29 is after the 10. Now we compare 29 and 14. 14 is smaller, so we will again swap 14 and 29 because 29 is bigger than 14. Now here we can see that 29 and 37 we don't have to swap because 29 is smaller than 37. So we will move on to the next one. 13 is smaller than 37. So we will repeat this process until we get the largest number at the back. So now we can see that the largest number 37 is at the back, but the bubble sorting is not done yet because we still have to sort each and everything once we have already get the number from the smallest to the largest. So I am going to sort, but it is the same process, just the 37 at the back we don't have to disturb. So after every lap, after we have the largest number at the back, we don't have to arrange the largest numbers. So after I have sorted everything out, this is how it looks for the bubble sort. It is very simple, systematic, and perfect for small races like this one. So next we are going to the insertion sort. For the insertion sort example, we have all of these dances as the numbers, and each dancers they want to join the perfect spot in the dance line, but they must shuffle left and right until they find the perfect position. So for example, when 29 comes onto the dance floor, it doesn't have to move anywhere as it is the only number in the dance floor. So when 10 comes onto the dance floor, it is going to move to the left as it is less smaller than 29. So when 14 comes onto the dance floor, it is going right in between 10 and 29 because 14 is smaller than 29 and larger than 10. So 37 is, it doesn't have to move anywhere as it is larger than all of these four numbers here, all of these three numbers here, 10, 14 and 29. So after that, when 13 comes onto the dance floor, it is going right in between 10 and 14 because 13 is larger than 10 and smaller than 14. So this will keep on repeating until all the dancers are in their right position. So after all the insertion sorting has happened, now we can see that the smallest number 5 and the largest number is 37. So next up is the selection sort. In my opinion, I feel like selection sort is my favorite because it is straightforward. So just imagine all these numbers are as treasure hunters searching for smallest treasure. So each treasure searches the entire group to find the smallest one, picks it up and places it in the treasure chest, which is the sorted part. This continues until all the treasures are found and the chest is full. So the first step, 29 will begin its search, and they check every single number and discover that 5 is the smallest. So they pick the 5 and they place it in the chest, starting the sorted part of the array. Next, number 10 will search their through the remaining numbers and find that 8 as the next smallest treasure into the chest it will go. So this hunt will continue as each hunter searches for the next smallest treasure. So the 14 will pick up 10 as the next smallest number in the treasure, and the 13 will pick up 12 as the smallest, and this will repeat until all the treasures are found and they are perfectly sorted. So this is how it will look after everything is sorted and the chest is full and it is in perfect order. So for the next sorting, we have the merge sorting. The merge sorting is actually we have to divide the array into half, and then we will sort the divided array while rearranging everything, and lastly we will merge everything together. So that is why it is called the merge sorting. So in this example we have 10 numbers. So in these 10 numbers I have divided 5 on the left and 5 on the right. So the right side of the array, we can see that the 29, 10, 14, 37 and 13 I have divided into 3 and 2, and from that 3 and 2 the 29 is larger than 10, so the 10 will be at the front. So here we can see I have already sorted the 10 into the front, while the 14 is in the middle because it is lesser than 29, and the 13 and 37 has also been swapped. And on the right side of the array we have the 3 array, which is the 25 and 8 and 12 and 15. The 12 and 15 we don't have to do anything as the 12 is smaller than 15, so we only have to rearrange the 3 numbers on the left. So after rearranging everything, lastly we have all the numbers from the smallest to the largest. So that is the merge sorting. After sorting all the numbers on the left, here we have 10, 13, 14, 29 and 37 in the correct order, and also on the right side we have 5, 8, 12, 15 and 20 in the correct order. So finally, when we are merging both of these together, we will merge as we are positioning each and every numbers from the smallest to the largest. So finally we have the quick sort, which is the divide and conquer algorithm that sorts the array by repeatedly dividing into smaller sub-arrays and sorting them. So first you choose any element. To avoid the worst case scenario, we just choose random element. So for my preference, I chose the pivot as a 13. So after choosing the pivot, we divide it as to the right element and also the right array and also the left array. So for the right array I have here is the left array I have here is the smaller numbers than the 13, and for the right array I have here is the larger number than 13. So after dividing it, we still have to choose the pivot. So after that I chose 5 as the pivot, and all the larger numbers than 5 are here. And the next, for the right array, I chose the 14 as the pivot, and all the larger numbers are at the right side of the pivot. So after continuing everything, we will have the sorted array here. So here I have made a very simple comparison table between all types of the sorting, how it works, and also the use case of all the sortings. So I hope that the stories I have made just now for all the sorting was a bit easy to understand, because personally for me I would be able to adapt to the topics much easier if it were in a story structure. And thank you so much for watching. That is all for my video.